Okay, guys, we are live. So, hey everyone, and welcome back to Geeks for Geeks. Guys, in this video, we are going to discuss and also we are going to create a Python project on how AI and big data control millions at Maha Kumbh. So, what is Maha Kumbh? So, Maha Kumbh is an ongoing event in India right now at Prayagraj, and this event actually comes in uh, I guess 144 years, right? So it's a very major event, and a lot of people are actually crores of people are actually going to participate in a span of this 1 2 months. Okay, so you can say that, okay, something's happening. It's a very great opportunity. A lot of people would actually go on this event at Prayagraj. Great. But what would be the government's responsibility? The government's responsibility is majorly to take care of people's like the gathering of the crowd. Obviously, in a single day there would be lakhs of people. Okay, in some days there would be more people, in some days there would be less people. For example, right now today is Sunday, so a lot of people are actually free on Sunday. They have their holiday on Sunday. So I think most people would actually go there on a long weekend or something like that. Most people would go to Prayagraj. So there's a high probability that during weekends traffic is high, and during normal weekdays traffic is low, or at some major days traffic is high. Suppose at some Purnima or at some specific day, there is higher amount of people, right? So there you can actually implement, okay, today we have high probability of people. Okay, so I'm just giving you small hints right now, what kind of logic you can use in future to actually know in what days particularly I am gonna have high amount of crowd. Okay, but in today's video, what is the main agenda? Okay, so in today's video, like, we are gonna discuss different fields. Okay, different fields, how government can actually use AI and big data. Okay, the theoretical part, how we can actually use these things into controlling crowd, and obviously this is gonna save millions of people's life, because some people have died there, some people have been injured there, some people have been gone missing there. So there are some bad sides of everything. Okay, so the goal is to avoid this. Okay, the goal is to avoid this mishappening. Okay, nothing must happen with anyone. And how can government use our technology, AI and big data? We have to discuss that. But that would be theoretical part. What would be the project part? In project part, we are going to build a Python based project. Okay, to which we are going to give a CCTV video. Okay, to give a CCTV video, and in return we'll get person count, right? Okay, so we have some live chat comments here. Neeraj lab, when it is going to start? Okay, it has started right now. What's the duration of the webinar? It would be around 1 hour. Okay, all right. So if you have any doubts, please ask me in the live chat. I'll be responding them in a while. Right? So yeah, let's discuss the theory part first. Then we are going to start building the project. Okay. The project would be solely based on Python. Okay. You need to have some knowledge of image or video recognition libraries like YOLO, OpenCV. Right? So you need to have some knowledge. If you don't have the knowledge, I'll be explaining the code to you so that you'll get the idea what I'm actually trying to do. Okay, but I would say in prerequisite you must have that knowledge. Or if you are just a beginner, you don't know much about it, if you know about Python, that's also fine. You can learn about it later. Right now try to build the project out of it. Okay, so that you'll get some interest. Okay, I'm using OpenCV or YOLO in this project, let me learn about it later. You can do that too. Okay, I always used to do that whenever I found something exciting. It's like even this image recognition part, video recognition part. Also, first I built a simple project. Okay, saw on YouTube and built a simple project. Then later on, I learned about that library. Okay, so we're gonna discuss that at the end. Okay, we are going to make a project out of it. Right now, first, let me just write some basic things what we can do. Manoj is asking, what are you building? So let me just show you the demo. Okay, let me just show you the demo. So basically, after some time we are going to start building this. Okay, today only, in this video only, we are going to build this. Okay, we are going to write this code. The purpose of this code would be very simple. It would be playing a video. Okay, it would be playing a video like this, and the aim of this is to count number of people. How it's going to help? Pretty simple. If you are at a crowded place, okay, suppose right now, at suppose my room, okay, it has a capacity of around 10 people maximum, right? If there are more than 10 people in my room, it would be crowded, it would be overcrowded, I can say. Okay, it still can, a lot of people can still be adjusted. If you want to fit in 50 people, definitely you can fit in 50 people, but comfortably 10 people can fit in. Okay, so I would have a threshold limit of 10. I'm just giving an example of my room. Okay. And if there are more than 10 people, suppose 15 people or 20 people, then I would start alarming. Okay. I would, the authorities would start alarming. Okay, there are lots of people in this room. We need to do something, or we need to remove people, or we need to alert people. Okay. So this would actually be very useful in places like Maha Kumbh. Why? Because here, suppose we can set a limiter of 1 lakh. Okay, only 1 lakh people can be near ghat. Okay, so we'll pass CCTV cameras, we'll have CCTV cameras near ghat. Okay, and it would actually maintain a count of people. Okay, so don't be confused. It's like how it would maintain count of people. There are so many peoples. Obviously there would be so many peoples, but this library is very much capable of dealing with original faces. Okay, recognizing faces. So it's a very powerful library. Don't underestimate it. How it would memorize the lakhs of people's face. No, obviously if you have the camera too much far away, obviously it would find difficulties. So we have to place some amount of cameras so that the count is maintained and the total sum is taken, right? So I'm gonna assume that you have somewhat CCTV camera placed like this. Okay, somewhere at the entrance where the path is narrow, and some people again and again come. Okay, so that not lots of people would rush up to your CCTV camera. You can assume some people, around 5 to 10 people at a time, come towards your CCTV camera, so that our Python program also runs efficiently. Okay, so CCTV camera position is also very important. You can't place it a crowded area of lakh people. It won't be able to recognize people individually. Okay, you need to place it somewhere so that some amount of data is fed again and again and again, so that the count is maintained again and again. I can assume that you would pass a footage like this. I picked it from a free resource, that's why I picked this one, but you can pick an original video of Maha Kumbh if you get something. Okay, due to copyright issues, I just picked this copyright free video. Okay, सर पम्पलेट्स और होर्डिंग पे पीपल हुए तो वो काउंट होगा या नहीं? Actually, Lokesh, this is very interesting theory which I have tested on my own. Okay, so this library specifically, sometimes it misbehaves. Okay, the training of it happens like that. Okay, but I think they are working on it. But most probably it works fine. But in some cases, it might detect the pamphlets and hoarding. But this is the problem with the library. Okay, this is the problem with the library. If you have any better library, you can use that better library, better pretend AI model, whatever you want to create. Okay, so but right now we are going to use YOLO. Okay, YOLO, you only live once. Right? uh, the full form of YOLO is you only live once. But in Python, let me just show you. So in Python, you can see you only look once. Okay, so it's just a real-time object detection system. It can detect multiple things, not just people. It can detect cars, vehicles, exactly. It can also detect faces. How face detection would help us? Please tell me in the live chat how face detection would be very helpful. In what case face detection is a very useful thing? Okay, please tell me in the live chat. So yeah, these are some things, and you can read an article about it. We have actually added an article at Geeks for Geeks. Please feel free to read about it to just get an idea what is computer vision. By the way, whatever we are having here in this project, okay, let me just run this project for you so that you can understand it deeper. Okay, so for running this, I would just like later on I would write the code, but assuming that we are just testing it for now. Yes, Krishna said in finding missing people. Yes, exactly. So guys, here you can see that our code is trying to count people. Okay, so I'm just running the code for now. Later on, we'll write the code obviously. So you can see right now it's counting people. Okay, it's counting people, and you can see it's almost very much accurate. Okay, the count is obviously increasing and decreasing because it might false detect people, and then it would recognize, no, 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 I have already counted the person. So it would increase and decrease, and some person might go away from the camera. So according to that, count is also changing. Okay, so this is actually something which is very good in this library. But yeah, you can also don't allow to decrease the count if you want. Okay, right now the count is happening because in this frame it's assuming there are 12 people. Okay, in this specific frame. Okay, so you need to place it in some location where you are expecting, okay, the crowd would be here, and obviously the CCTV must be facing close to the people. Okay, so somewhere near the ghat, you can assume that yeah, you are placing a CCTV camera close to the people, not too far away from the people. Okay, so that it can real time guess it. Okay, it means the child being carried by the women. Haha, I didn't saw the child. Okay, yeah, it happens, right? But yeah, our goal is to build something like this. Okay, maybe better, maybe someone can build better thing, but our goal is to at least address the problem and build a system to at least know, okay, in this area the maximum 20 people, I think 20 people would be crowded, okay, in this area, if you guess. Okay, so I can actually pass a threshold limit as a security guard. I would see, okay, there are more than 20 people in this area, I should go and adjust the system there. Okay, right, right, but it would require a very powerful processor, would it? I think so, not very much powerful. Okay, if you are working on cloud, okay, using cloud computing, either you can use cloud computing. Okay, we can add this code to our cloud server and then run there. Okay, like chat gpt does. Okay, chat gpt I'm sorry, like other thing does. But if I talk about chat gpt, they have their own systems. Okay, similarly, if we have our own systems for this, yeah, a little bit powerful processor would be needed. But how many CCTV cameras are you gonna put? Like people, the government is spending crores on this Maha Kumbh project. Won't they be purchasing a very good PC for it? Okay, maybe a lakh or 2 lakh rupee PC and some set of PCs so that they can monitor the CCTV camera. Like, yeah, obviously some little bit costlier PCs would be used, but not that much costlier. It's like lakh, 2 lakh rupees PCs would be fine, right? I don't think it's a CCTV photo captured by the camera. Yes, definitely. But I picked the video. I picked the video, which is first of all copyright free. Okay, I can't use this on YouTube. Okay, but I use this one because this is copyright free. I use it from a website named as, let me, Pexels. Okay, I think I took it from Pexels. And the second thing is, this is the exact kind of video I'm looking for. Either it's from CCTV camera or from our mobile, doesn't matter, but the exact kind of video, because the faces are little bit clear of people. Okay, so that's what we want. Okay, so that we can later on use these kind of things in finding missing people also, right? So that's it. Krishna said we need a powerful processor for an efficient real-time. Yeah, definitely, yeah, definitely. I'm considering that. Okay. Like in our case also right now I'm running on this laptop. Okay, just hear me out. My laptop right now, okay, like I haven't tested it to a very extreme case where we have lakhs of people. Okay, but right now my laptop is, it's somewhere costing around 60,000. Okay, it has a i5 11th gen processor, gaming processor, and right now it's handling my live session also, and my other Chrome tabs also, and also the code. So kind of this is an average processor and it's handling some amount of my work very easily. Okay, so some powerful processor definitely would be dealing things way more better, and for large amount of people, like for lakhs of people's calculation, definitely we would need a higher amount of a processor. Okay, and obviously the GPU also. Okay, because for some other AI processes we need GPU, right? So yeah, this is something which government would need to consider. If they are adding CCTVs, they would need powerful computers. Okay, this is something needed. Okay, right. So now guys, let me first of all discuss what solutions do we have. Okay, someone was asking for the link of this, so you can just search for YOLO Python, and then you would get an article of Geeks for Geeks, or you can get official article of Python. Okay, right. Okay, so now guys, I'm going to discuss the problem, exact problem, and the solutions which the AI technologies or big data technologies can offer us. Okay, so first of all, what can we do? First of all, we need to collect data. Okay, so first of all we need to collect data. Let me just draw something here. Data collection from sources. Okay, what sources can we have? What sources do we have? So we have sources like CCTV cameras, drone surveillance, we can have drones also. Then we have thermal imaging cameras for night vision. Okay, so we can have three types of cameras: CCTV cameras, drone surveillance. Okay, right now drones are very majorly used at Maha Kumbh, you can watch videos of that. Okay, then we have thermal imaging cameras for night vision. Okay, how we would do in night, we can have thermal imaging cameras. Okay, so first thing is data sources. Okay, what other data sources can be there? You would have GPS. Okay, so mobile tower signals to estimate crowd density. Suppose at Mahakumbh right now more people would be calling. Okay, obviously the data, like the mobile tower would be having more dense network. Okay, more amount of people would be using the bandwidth of the mobile tower. Okay, obviously in that area the crowd would be more. Okay, so this is one more estimate to find crowdness. Okay, if you don't want to add CCTV cameras, you can actually look at the data of mobile tower. Okay, or else you can check Google Maps. Okay, so in Google Maps, by contacting Google team obviously, so you can actually ask data from them. Hey Google Maps team, I need data of current location right now. Is it lots of traffic or not? So Google Map keeps the data. Okay, so a lot of people would be actually using Google Maps, a lot of people would actually not be using Google Maps. So this is something very like less amount of people would be using there. But yeah, this is an option. We can just get data from Google Maps, and we can assume, okay, normally 10 people use Google Maps here, but right now 1,000 people are using Google Maps here. That means I can just get the ratio out of it. Okay, a lot of people are actually using Google Maps here. That means it might be crowded there. Okay, so this is also going to give us estimate. Or else, what else can you have is you can have UPI transaction records. Okay, so you can check that in this current, you would say current shops. Okay, whatever shops would be there, there would be UPI codes. So you would see in these current shops at Mahakumbh, there are more UPI transactions happening than last day or last month. That means today it's very crowded. Okay, so this is also going to very helpful to check via UPI transaction. So this is a solution which government can use. Okay, and the third thing would be something else, which would be social media check-ins. But this is something not reliable, because social media check-in, suppose I clicked a photo today and I'm posting it tomorrow, or I would morph it using AI like this thumbnail. Okay, so social media is very less reliable or that, but it's an option to check. Okay, right now the city or the place looks like that, overcrowded, I must not go there, something like that. But yeah, the majorly all the things would be CCTV cameras, drone surveillance, thermal image cameras, then mobile tower signals, location data by Google Maps, and UPI transactions. These are something very useful sources which government can use. Okay, then after that we can have some IoT sensors also, like smart sensors at key points. Suppose I have seen a sensor, IoT sensor, which is basically at the entry gate, which would actually check the footfall. Okay, suppose it's like I gave my first step. Okay, that means I'm person one. Okay, then I went away. Okay, it's a thin line. Okay, it's a thin line, kind of a security guard would say, add your foot in this line and then go away. Similarly, add your foot. Similarly, person would be incremented. Okay, so kind of IoT sensors can be used in that. If you don't want to spend a lots of money on these CCTV cameras or computers, you can add a sensor. Okay, or else what else you can have? You can have RFID wristbands for tracking registered devotees. Okay, so this is also something very useful. You can have RFID wristbands. So what else you can add to this wristbands? You can actually add some basic information to each wristband. Suppose if someone went missing, so with the help of that wristband you can find info about that person. Okay, so first of all you're going to provide the wristband at the entrance as a security guard. There would be many security guards there, since it's a very big event, so there would be many. So those security guards can give RFID based wristbands to people, to everyone. I know it would be costlier, it would be costlier, so but it's an option. If government has huge amount of money to spend on it for people's safety, then why not use these things, right? So RFID wristbands can be actually used for tracking, for storing people's information in just a QR code. uh, I actually got this idea with the help of a startup. I think a lot of people might have heard about Shantanu Naidu and some people who work for welfare of animals. So I have heard about a startup. Okay, it was kind of for dogs, for animals. Basically, the dogs have a kind of a patta, okay, or whatever you call it. Okay, I don't know what we call it in English, and in that they had a small QR code. Okay, whenever people scanned that QR code, they were easily able to find, okay, this dog is belonging to this owner, the location, the house of this dog is this one. Okay, so they can easily find the house of the dog, so that if a dog went missing, they can easily find the dog, right? So yeah, somewhat similarly some bands can be created for people. Okay, so that easily some info can be found for the people. Okay, so this is an option which we can use, okay, to find people. All right, then the next would be ticketing system, but ticketing system is very less reliable in these kind of places. We need an online based ticketing system, and again a QR based ticketing system. That would be really helpful. Okay, so in case people went missing, scan the QR code, know the information about that person, and send him back home. Okay, that's something they can do. Okay, now what else we have? So now what would be the big data architecture for Maha Kumbh? Let me discuss that. So big data architecture for Maha Kumbh. Right now we discuss how we're going to collect the data and how it's going to be used. Now we're going to discuss how big data is useful here. So big data architecture. Okay, big data architecture, how it can be used. So to process and analyze such huge amounts of data, okay, which we previously got, okay, we need big data architecture, right? We need big data pipeline. Okay, so first of all, for some people who know about big data, for them I'm telling, we have data ingestion. Okay, so we have data ingestion. like collecting data. So how you're going to collect the data? We are going to collect the data using CCTV, drones, and GPS. So we can use Apache Kafka, which handles real-time data streams from CCTV, drones, and GPS. So it just brings all together, and then we can analyze the data wherever we want. So we can actually use Apache Kafka for that. Or we have Flume Spark Streaming, which collects sensor-based data, right? Then for data storage, we have Hadoop HDFS, stores large amounts of unstructured video, image, and text data, right? Then we have Apache Hive, which stores structured storage for ticketing, RFID, and entry data. Then we have Amazon S3 for storing again images, videos, etc. Okay, then for data processing, like AI ML kind of thing, which we are gonna do, we can use Apache Spark, processes real-time data. We can use TensorFlow and PyTorch AI models for crowd analysis from video feeds. Okay, and we can use BigQuery and Snowflake for analyzing trends and visitor movements. Okay, then for visualization, for charts and graphs, we can use Tableau and Power BI for dashboards showing crowd heat maps. Okay, then we have Elasticsearch for real-time logs and alerts. Then IoT notification system, kind of an SMS system which gives alerts for overcrowding. Okay, so these are the things which we can have in big data architecture. Okay, so let me just talk about the use cases of AI and big data at Maha Kumbh. Then we're gonna jump to our project. Okay, so this would be the third point. So AI and big data use cases. Okay, how we are gonna use them. Okay, so this would be a third point, very useful point. Let me discuss that. Okay, so first of all, crowd density and stampede prediction. We can use AI in this. Okay, so AI detects overcrowding using CCTV and drone feeds. Okay, alerts authorities if crowd density exceeds, predicts stampede risk using movement patterns. Okay, so it would be very useful for crowd density and stampede prediction, right? Then second useful case of AI and big data would be smart traffic and route optimization. So it analyzes GPS and mobile data to track congestion. Okay, suggest alternate routes. So Google does this, Google Map does this. If one route is having lots of traffic, so it would say other would be the shortest route. Okay, so kind of it suggests, okay, here we have less traffic, so you would reach here in less time. Okay, some alternative route Google Maps would suggest. Okay, and also predict travel time for emergency responders. Suppose right now here we have some traffic and here we have an ambulance, so it might just give an alternative path and tell, okay, from here the path might be longer but you would reach faster as compared to this short path which is overly crowded right now. Okay, so very useful. And then we have missing persons and facial recognition. Third thing, missing persons and facial recognition. So AI can be used here. AI powered facial recognition project like we are going to build today. We are going to build crowd counter, but similarly you can build a facial recognition project which can easily recognize people and match with the photo you provide. Okay, so you're going to provide a photo to our program, and then the CCTV feed would be matched with that photo. Okay, so if the person's photo matches with the CCTV feed, that means you found the person. Okay, you found the person. Okay, so you can easily find the person in the crowd using the photo of that person. You can ask the photo from the family members and so on, and you can find that person. Okay, so with the help of AI you can build a project like that. Okay, so it matches photo from missing reports with live camera feeds, sends alert to authorities if match is found. Okay, then we have fourth, which is sentiment analysis for crowd mood. Very important. So this is something unique, which is it analyzes tweets, posts, and news for signs of stress, panic, and fear using social media platform. Okay, so you can use sentiment analysis from social media, right? It detects potential protest and security threats, helps in deploying security forces proactively. So if you see in social media, there are lots of negative comments right now. Something bad might happen due to this. Okay, some people might be offended due to something. Okay, then definitely we need to increase police force there. Okay, then the fifth thing would be IoT and wearable devices for health monitoring. So RFID wristbands and wearables track health conditions of people. Okay, it monitors heartbeats and temperature. So we can use that, but it's a very costlier thing. So kind of let's ignore this one. Okay, wearable devices, it's not that much feasible. It's very costlier because for lakhs of crores of people, obviously you won't be having wearable devices to measure the heartbeat and temperature and so on. But yeah, at places we can just add some machines so that if someone has some weakness, so they can just go there and have a physical assessment. Okay, then we have AI powered food and water supply distribution. Very important, very important. So it predicts food and water demand, so in different shops where food and water are there, like for government also, like I went to Vaishno Devi. Okay, Vaishno Devi is a temple. It's a very big worshipping temple at Jammu Kashmir. Okay, so I went there. So basically, there lakhs of people visit there every day. Okay, visit there every day. So obviously, government also has like facilities for providing food and water and different basic needs. Okay, so we can actually use AI based again object detection technology to recognize, okay, right now we have shortage of food, we need more food, so kind of alert to the society. Okay, so again it actually prevents food wastage. You would be making limited amount of food, and then again when shortage is there, you would bring more food. Okay, so kind of it's very useful AI technology for detecting objects, detecting food items and quantity would be really useful for this food and water supply, right? So NGOs and government can actually allocate resources effectively, and there would be very less wastage of food, right? So these are some things which I have suggested. Okay, 6 points which AI and big data can be used for. Number one, crowd density and stampede prediction. Number two, smart traffic and route optimization. Number three, missing persons and facial recognition. Number four, sentiment analysis for crowd mood. And number fifth would be IoT and wearable devices, which you can ignore. Number six is AI powered food and water supply distribution, right? Right? Yeah, Krishna has a suggestion. Train the AI with lots of data, human faces and bodies. Get a NASA computer. Make sure we Indians don't break cameras and map. No, no, we don't need to try train that. You are not understanding this one. Okay, let me clear this. uh, Already there is a pre-trained AI model. Okay, suppose we are using YOLO. Okay, what we are going to do is, suppose I am missing. Okay, I am missing. Okay, I am, suppose for example, in this CCTV footage. Suppose I am this guy, red shirt one. Okay, I am this guy. Suppose. Okay, I am missing. Okay, but you have my photo, right? So I'll compare my photo with this footage. Okay, with this footage, wherever my photo matches. Okay, wherever my photo matches, I'm that guy, na. Easy. I don't need to train model to like first to just everyone's faces would be trained, patterns would be explained. No, it would be real time. I'm just going to provide my photo, and then I would have a CCTV footage. From my photo, I would find my shakal, I would find my face. Pretty easy. That's it. That's it, right? This is what the facial recognition would do. You don't need to train it completely. So you don't need to go to NASA. We already have reached there. All right, so let me just now make the project out of it. Someone is asking, it's beginner friendly. Yeah, it's beginner friendly, but if you are good at Python and also you are interested in object detection, even if you don't know that much about it, that's fine. You can learn about YOLO later, but if you know about YOLO or object detection, it's gonna be very easy for you. Okay, so now guys, I'm gonna build this project. Okay, I'm gonna build this project. Okay, let me show you again what we are going to build. So if I just run this, you would see that basically we are having a CCTV footage which is counting number of people, and you can see according to this count is increasing. Okay, so a CCTV footage would be shared with the security guard, and he would see, okay, right now there are 12 14 people, it's fine, not crowded. But suppose if there are 30 people, okay, usually there are not 30 people, there are 10 to 12 people only in the street. But if there are 30 people, that means it might show that yeah, it's crowded. Okay, the area would be crowded. Okay, so yeah, it's gonna be very useful in that case. So let me just build that for you. And to actually close this, we press Q, then it would be closed. Okay, so let's build this. I am simply going to create a new folder here, and I'm gonna name it as Maha Kumbh Crowd Detection Live. Okay, so I'm gonna open this with VS Code. All right, let me just zoom in. And now guys, here, if you have any doubts, you can mention in the live chat. Okay, but let me just complete it. Okay, so first of all, you are gonna need this Coco names file. Okay, I'm gonna provide this file. uh, I'm going to provide this file in the GitHub repository. At the end of this video, I'll be uploading the GitHub code. So I'll be providing everything there. Okay. So Coco names, it's kind of a list of names of all the objects our model can detect. So it can detect person, bicycle, car, motorbike, and so on. So our model is very capable of detecting lots of things. Okay. YOLO is capable of detecting lots of things you can read. Okay. Then we have a video, okay, which we are gonna use. Instead of this, you can use live webcam footage also. You just need to change a single line. Instead of this, we are using a video, okay, because we need crowd footage, right? Not a single person's footage like me. Okay, so that's why we are using video. Okay, so this is it. Now after this, we have the configuration. Okay, so configuration is again inbuilt, okay, pre-built, provided by YOLO. You just need to download it. Okay, so you can just search for it, or else I would provide you my GitHub repository. From there you can get the configuration file. Okay, then similarly we have the weights file. So again, this weights file is provided by YOLO. It's kind of the model which we are using, so we need to have the model, right, so that we can use the model. So these are the things which are needed, prerequisite. And the third thing is Python must be installed. Okay, now after this, I'm gonna start writing my code. Okay, so I'm gonna say import cv2. Okay, so we're gonna use cv2, and then we're gonna use numpy. So I'm not going to go at that much detail because I'm assuming lots of people might not have a knowledge of this. So but I'm going to explain this ऊपर से, so that you'll have a very good idea, and also you'll be able to write this much. Okay, so that if someone asks you what you have built, then yeah, you would have an idea. Okay, this, the purpose of this line is basically this, the purpose of this line is basically this, right? That's what I'm trying to say. Okay, let me just share the links. Okay, let me just share the links. I'll share the links here. Okay, I'll share the links here. So links.txt file. Okay, here I've added the link so that you can directly download the files. Okay, so that would be better. You can download the files from here. All right, and you can download the video from any free resource or from YouTube. Since this is a YouTube video, I can't use any copyrighted video. That's why I'm using a free video, copyright free video. I just downloaded it from Google, from a website like Pixels, right? Okay, okay, so yeah, I've just added the links here, and later on I'll upload the code to GitHub so that you can extract it from there. Okay, so yeah, now let's start. I'm going to explain this. So first of all, I am using cv2. Okay, I'm using cv2. Cv2 is basically used for video processing and object detection. Okay, cv2 is a package, it's a library which is used for video processing and object detection. Number two is numpy. Numpy is used for handling mathematical operations and arrays. Okay, clear? Now let's continue. So first of all, I am going to say that we are going to load our model. We are going to load our model, which is YOLO model. So I'm going to say net equals cv2 inside computer vision. Inside computer vision, we are going to load our model. So here we are just going to provide our weights. Okay, so YOLO dot weights. So this is a pre-built model, but if you don't want to use a pre-built model, you can create your own models also, or some third-party models also. This is also fine. Okay, but yeah, YOLO is built by I mean it's not pre-built, it's like already built model. We didn't build this model, it's already built by someone else. Okay, we are just using it. So you can build your own models or you can use any other third-party models also. Okay, so I have added my model. Okay, we have added the configuration file and we have also added weights. Okay, we have also added weights, right? So basically we load a pre-trained YOLO v3 model using its weight, okay, and the configuration. So YOLO is basically a real-time object detection model. It's very powerful, that's why we are using it. Okay, then we are going to get layers name. Okay, get name of the layers of our model. Okay, so basically it's gonna give name of the layers. Okay, so we are just gonna say layers underscore names equals net dot get layer names. Get layer names, I'll explain it later, a lot of things later, so just to wait. And then similarly we have out layers variable. So inside this we are just gonna say we are gonna get output layers needed for detection. Okay, we're gonna get output layers needed for detection. So layer names I minus 1 for I in net dot get unconnected out layers. Okay, right? So basically we got the layers. We're going to discuss a lot of things. If you have any doubts you can ask me in the live chat. Okay, so now we are going to load our names data set. You can see these are all the names which I can detect, okay, which I can detect using our model. So we need to load it. Okay, we also need to load it. So I'm just gonna say that with open and coco dot names, right? Coco dot names. I'm gonna read this files as f. Okay, and here I'm gonna say classes equals lines dot script for line in f dot read lines. So basically what I'm saying here is I am actually storing this into a list. Okay, storing this into a list of classes. Okay, basically classes would be containing all these names. That's what I'm saying here, right? So load the list of object names from coco.names, which contains 80 classes, person, car, dog, etc. This helps the model to identify different objects in the video, right? Okay, so again I'm telling right now, if you are very much confused about Python syntax, don't worry, just create this project for now. Later on you can learn Python better and also you can learn the library better. Right now I'm assuming that you have some knowledge of it, so I'm just explaining you upar se from above. Okay, so this helps model identify the objects in the video. This coco names is very important. Okay, so I think everything is fine. Now here we are going to get our video also. We need our video also. Okay, first we have our model, then we have our list of objects which the model can detect. And the third thing would be video. Okay, so I'm gonna say capture equals cv2 dot video capture. Okay, you can also capture webcam here, you just need to change the line and it would capture the webcam. So video dot mp4. Okay, okay, so now it would start capturing the video. It would load the video file, I'm sorry, it would load the video file into this. Okay, so we have this. Now guys, we are gonna say that while cap dot is open. Okay, I'm gonna get frame equals cap dot read. Okay, if not, then I'm gonna break. Now what's the meaning of this line? So I'm simply saying I am reading the video frame by frame. Okay, and if the video frame is not gotten. Okay, if you don't get the frame, that means if you have read it, okay, completely read it, if you don't get ret variable, then it would break. Okay, so easy. Okay, so we basically get two parameters, ret and frame, from a video which we read using cv2. Then if you don't get this, that means the video has ended. That means the video is of 10 seconds, 10 seconds are over, and you didn't get any frame after that, so it would break. That's it. Okay, so now I am gonna say that else you are gonna get height, width, channels, that means different properties, okay, from the frame. So frame dot shape. What frame? So frame is basically nothing but right now you can see that suppose after 2 seconds this is the frame, after 4 seconds this is the frame, after 6 seconds this is the frame. So you can see basically I'm just getting this image, multiple images, multiple frames. Okay, and I'm getting the whole height and width. Okay, whole height and width and channels, okay, from the frame. So basically we got a single image, then another image, then another image, then another image, again and again and again and again. Okay, so yeah, it would give me height, width and channels from the frame. Okay, now I'm gonna create a blob out of it so that it's readable. So first of all we extracted frame dimensions, height, width and channel. Okay, then we're gonna convert the frame into blob, a format that model would understand. Okay, model doesn't understand these things. Okay, it would know what to do. I would be converting it something, you can call it a matrix, 0 1 0 1 and something like that, so that model can recognize, okay, here we have a person, here we have a person, here we have a tree. Okay, like this. Okay, so for that we need to convert it first into a model, that is a image would be converted in kind of a matrix. Okay, so cv2 dot dnn dot blob from image. Okay, here we are going to provide our first of all frame. Okay, then here are some parameters which you can provide as it is. Okay, as it is 392, the dimensions which I want as an output is 416 416 and 0 0 0. You can just provide it as it is. Okay, true, crop, false. Okay, I would say please try to read more about it so that you can understand better. For now I've just written as it is. You can see that the properties are basically the image, the frame, okay, the scale factor, the size, the mean, swap, crop and depth. Okay, so these are the properties which you can use. You can read more about this, but if you are confused you can just hover on it, then you would understand, okay, this is the purpose. And if you see that this is the purpose. Okay, so yeah, you can just hover on it and then you'll get more idea also what are the things. Okay, so basically I'm converting the frame into a blob, okay, a format that model understands. Then I'm resizing it to 416 416, that is input size YOLO expects. Okay, then I'm sending the image to YOLO model for pre-processing. How we gonna send that? So we're gonna say that net dot set input. Okay, here I'm sending the model, the blob to the model. Okay, I'm sending it, and then output equals net dot forward outliers. Okay, so you'll get output inside this variable. Okay, right? Okay, fine. Now we have the output. Now we have the output. So first of all we are gonna get lots of boxes. Okay, lots of persons boxes. Okay, then also we'll get confidences. Is this a person or not? I am 50% confident, I am 70% confident, I am 30% confident. Okay, if this is a person. Similarly there would be array of persons. This is 30% confidence, this is 40%, this is 50%. So confidence is basically that. Then the class IDs would be, this is a person or not, this is a person or not, this is something else, this is a bicycle and so on. So class IDs are that. So I'm gonna just say that boxes equals blank, confidences equals blank, and class underscore IDs equals blank. Guys, if you have any doubts, please mention in the live chat. I'll be clearing up them in a few minutes. Okay, just wait, let me first finish this. Okay, so it won't take long, 10 to 15 minutes more, then it would be ended. Okay, so here we are gonna say that now we're gonna run loop. Why we're gonna run loop? Because obviously there would be multiple frames. Okay, multiple frames. So I'm just gonna say for output in outputs. Okay, for output in outputs, for detection in outputs. Okay, in output. Okay, so it would be all the frames, and it would be inside one frame we have multiple detected items, right? We have multiple people. Okay, so we have scores first of all. So I'm gonna store my scores. Okay, I'm gonna actually extract confidence. Okay, so I'm gonna say give me those more than 5. Okay, more than 5, the array item more than 5. Okay, so it would extract confidence scores. Okay, then the class id equals np dot argmax, and here we're gonna provide scores. So according to the score we'll get the class with highest confidence. Okay, either it's a person or it's a dog or it's a car, whatever confidence is highest, that would be the label. Okay, suppose this, is this a person? No. Is this a dog? No. Is it a mobile? Yes. So the confidence for mobile is highest, right? So it's a mobile. Okay, basically I'm trying to say that. Okay, so now I'm gonna say that we have the confidence equals score. According to the score we are gonna get it. Okay, so yeah, now after this I'm gonna say that if confidence is greater than 0.5, that means you are sure, you are 60% sure that this is a person. Okay, and we have an id classes, class id equals person, then only continue. If you are detecting a dog, I don't need a dog. Okay, I need a person, okay, you are confident, you are 80% confident, but you are confident about a dog. What else, what can I do for a dog? I don't want a for a dog. Okay, I want it for a person. Okay, so that's why I have to compare both of this. You're confident and you're confident it's a person. Okay, then only continue. Okay, so now here I'm gonna say, I'm gonna find, I need to create a box basically. Okay, so I need to find the center of that person. Suppose this is person, this is person, this is person. Center of this person would be here, center of that person would be here and here. We need to create a box around this, we need to create a box around this, we need to create a box around this center. Okay, so center x equals int, so first of all detection 0, right? And width. Okay, width. Now y center, center from y, so again height. Okay, w equals int detection 2 into width. Okay, so basically it's used for getting width and height of the box which we are going to create. So int detection 3 into height. Okay, now I'm going to say x equals int center x minus width slash 2. Okay, so you're gonna get the exact center with the help of x. Now similarly you're gonna get y, the help of center y minus height by 2. Okay, now you're gonna add it to boxes array. So boxes dot append, and here you are simply going to append x comma y comma w comma h. Okay, you are just adding it to boxes array. Okay, similarly confidences dot append and inside this you are gonna provide float of confidence. Okay, you're gonna provide confidence, you're gonna append that to the array. And similarly in class IDs, you are gonna append that class ID, okay, which you found, right? So it actually iterates through YOLO detections. If detected object is a person, it extracts the bounding box, it creates a box, okay, dimensions, okay, and it filters out the weak detection. If the detection is less than 0.5, it won't show it, okay. If you are not sure, if the YOLO is not sure it's a person, then it won't show it, okay, it won't show the box. But if YOLO is sure, 60% sure, more than 50%, 51%, 52%, or more than 50%, basically, if YOLO is sure, then the box would be created, else the box won't be created, okay. Then we are going to remove duplicate detections, okay. So for removing duplicate detections, what I'm going to do is I'm going to come here, okay, and I'm gonna say first of all indexes equals cv2 dot dnn dot nms boxes. So basically what it's gonna do, suppose this is a person, again this is a person, so if one box is created, I'm not going to create another box over it, okay. So nms boxes is basically it's like non-overlapping kind of stuff, okay. So I'm just saying don't overlaps anything, okay. If it's overlapping, don't show the overlapped stuff, okay. So boxes dot comma confidences, you're going to provide confidences, and also you're going to provide it the threshold, right? So you can just check what it needs. So it needs boxes, scores, score threshold, nms threshold, and so on, okay. So basically what it is, so let me just tell you the full form of NFS is non-maximum suppression. It removes basically overlapping boxes. So if one box is there and above this another box is here, so we're gonna remove this box, okay, so that only one box is visible, okay. So here we need to say that this is it. Now we need to say person underscore count equals length of indexes, right? Length of indexes, right? So basically in a particular frame, suppose 11 people are visible, so person count would become 11 because there are 11 items in the array, okay. So 11 people are visible, that's the person count, okay, and it would be real time, right? Now guys, I'm gonna show the box which we have. I'm gonna show the box, okay. So I'm gonna say for I in indexes dot flatten. What I would do is I would simply get x comma y comma w comma h from boxes, okay, from that specific index, okay, from that specific index, okay. Now I'm going to say cv2 dot rectangle, so I'm going to create a rectangle out of, first of all, in that frame, in that particular full size image, at the x comma y position we have the x plus width comma y plus height, okay. Then I need to tell the color, what color you want to show. So I want a green color box, okay. So I'm going to say 02550, okay, it's a color code for green, right? Now okay, I did a mistake. So you can see it basically has image, point 1, point 2, color, thickness, okay. So thickness of the line, right, 2 is the thickness, right? So you can see this is it, this is it. Now we need to also show a text, okay. So what text you want to show? So cv2 dot put text, okay, where you want to put text in the frame, okay. And what text. So I'm gonna say person. Okay, where you want to put. So the first point one would be x comma y minus 10. The second point would be um yeah, you just provided the index where you want to point. Then you want to say the font family, so font Hershey simplex. Okay, and then we have con and the color and the width. Okay, so basically put text basically extracts image text origination. Okay, font, and then font scale, color, thickness, right? So yeah, basically it's the scale. All right, so now what I need to have is I have put text. Okay, I have put text, so it draws a green line on the bounding boxes detected people and labels each person with the person. Okay, so this is what I have done. And what else I need to do? What else I need to do? I need to also show the total count also. Okay, I need to show the total count. How can I show that? So I can just copy this and paste it here outside this loop. Outside this loop, I can say in this frame I need to show the count. So count. Okay, count. And here I can show the person count. So person count. Okay, I can show the person count at this position from the top, that is 20 comma 50. Okay, so in the frame in top left corner I want to show the font. Then this, then after this you can also change the color. Suppose I want the color for this to be red. 255 255. Okay, so kind of reddish color. Okay, right. So I'm gonna give it, oh no, it's actually some other color. I'm sorry, it's not red, I guess. Okay, so now guys, what we are gonna have, which format it is it BGR or RGB? Okay, we'll see whatever color format it is. Okay, just wait. So right now we have added the text also. Now we need to show the frame. Okay, now we need to show the frame. Let's show it. So we are going to say cv2 dot im show. Okay, so we need to show the frame instead of the blank frame so that we can see the boxes. So I'm gonna show the frame. Okay, easy. Now I'm gonna say that if cv2 dot wait key, if someone presses 1. Okay, if someone presses 1 or else, and 0xff equals someone presses q. Okay, if someone presses q, then break, break. Okay, break, just stop the code. Okay, right. And then I'm gonna just say cap dot release. Once I stop the code, I'm gonna release my memory. Okay, so release and cv2 dot destroy all windows. Okay, so this is it. Now let's try to run this. So if I run this, there might be some error in line number 4. Basically the error is in line number 4. I have an error. Okay, so net cv2.tnn read net. Then we have YOLO v3 waits and the YOLO v3 config. Okay, let's check now. Then we have issue at line number 44. It's actually H, right? Then run, and you can see that it's trying to detect. Okay, very easily it's detecting people now, and you can see it's real time, right? So now if I press Q, you can see that it would stop the code, right? So this is the project, guys, which we created. Now you can see it was pretty simple. If you have some knowledge of object detection and YOLO, you'd be easily able to catch this. But if you found this difficult, don't worry. First, please have some knowledge of YOLO. Okay, learn about it. Okay, the purpose of this project is how you can solve the problem, okay, of crowdness. Okay, so kind of just a hint what else you can do. So basically, this is just a short problem which we have solved to calculate the count. With the help of this, we can actually know, okay, right now there are lakhs of people. I should increase the security. I should make arrangements better. Okay, kind of those things. So you can do those things, right? Right. Yuvraj, train dataset uses to fetch the information. Yes, definitely. We can use train dataset. Uh, basically, this YOLO model is basically trained. Okay, it's basically trained to identify what it's used for. It's trained for identifying people, bicycle, car, motorcycle, anything. It's already trained. You don't need to train it. Okay, if you need to find me in this CCTV video, you're just gonna provide my image and the CCTV footage. My image would be matched with every face, okay? Whatever face matches with the CCTV video's face, it's my face, right? Okay, if the image matches with the CCTV video face, it's my image. Okay, so I am found. So if someday I am lost, you can easily find me like that. Okay, so that's some other project which you can make using the same OpenCV and YOLO, right? So now, guys, I'm going to upload the source code to GitHub so that you can take the source code from there, and definitely you can add a GUI, graphical user interface, and you can add multiple functionalities also like face detection. But face detection is very useful in that case when we have to find some missing person. Okay, let me just upload it to GitHub now. Okay, so just a minute, then I'll share you the GitHub repository. Maha Kumbh GFG. Okay, I'm just going to name my repo like that, and just a minute. I think so. The files are too big, so let me just delete the other files. But the links of the files are actually in this. Okay, links. Okay, so you can easily download it from there. All right. I think okay. I'll keep the video for you all, but the other files are big, so I'm not keeping those files. Okay. Okay, I think, guys, now the source code is uploaded. So what you can simply do is it's available here. What you can simply do is you can go to my GitHub account. Okay, you can follow me here. Okay, right now I have 809 followers. You can just follow me here, right? Joy is here. I Joy. So if you wanna contact me, definitely you can contact me via LinkedIn. And in the repositories, right now I have created Maha Kumbh GFG. Okay, so you can just go here. You can mark it as a star, or you can find the repository name here. Okay, inside this, the source code is available. Okay, so you have links for the different configuration files which we have. Okay, I provided you the links. Okay, then we have test file, then we have sample video file, right? So that's it, guys. I hope you enjoyed this session. In this project, we created a simple crowd detection system where we can count number of people currently in the live CCTV feed, right? You can do that. Okay, but yeah, apart from that, I have also mentioned some other things which you can do using AI and big data. Okay, let me just show you that. So I have mentioned these things, and we talked about these three major things which we can do using AI and big data use cases. Then we discussed about big data architecture, what technologies we can use, and then the first thing was how we can collect data from different sources. Okay, so we discussed this first. Then, guys, we created this project to actually calculate how many people are currently there using CCTV footage, right? So this is it. I hope you enjoyed this session, and I will see you in the next one. Please definitely show me some more love by liking this video further. And also, guys, we have different courses. You can check out this, And also right now guys, we have like you can explore the Geeks for Geeks website. Okay, so currently, or maybe after some time also, there is a challenge named as 390 challenge. Okay, so you can participate on that challenge also. It's a very fun challenge. Basically, if you purchase any course and you finish 90% of the course within next 90 days, then you get 90% of the amount as a refund. So you can also check out that 390 days challenge, right? So that's it for today. I will see you in the next one. Till then, see you. A good day. Bye bye.